Now I'm going to do the third chapter of module 3, which is chapter 14, which talks about essential shell programming. So this entire chapter consists about 50 slides. So I will be doing it in two parts, part 1 and part 2. So the first 25 slides will be covered in part 1. So like you have already seen, you have executed some shell programs and the extension of shell files are .sh. So let's just revise. Most of it is something that you have already executed. So I'll just brush through whatever we have discussed so far in the lab. So when a group of commands have to be executed, they should be stored in a file. And the file itself is executed as a shell script or a shell program. So if you have some commands to be executed in a shell file or a shell script, then you call it a shell program and the extension of it is .sh. When I say a shell is created, usually the child and the parent shell belong to the same type, but you can refer it to a different shell as well, or you can specify a different shell for your script. So if you remember a shell program, the first line always indicates or starts with hash exclamation or hash exclamation /bin/bash or sh or whatever is the type of the shell it indicates on the first line of the shell script. Now, to edit a shell script, you can use any editor. I have already told you about the VI editor, but you can use any other editors available like the editor itself or gedit or nano or any editor can be used. Now, let's see a small sample shell program. The first line, like I said, tells you about the type of the shell that you're using. That is, it has to start with hash exclamation /bin/bash. The next line follows a description or a comment line which tells you the name of the file and a description of what that file does. So here the name of the file is script1.sh and the explanation says that it is a sample script or it is an example program. Echo today's date : date. So if you see, I have also told you about command substitution where you know that date is a command. So when you execute or when you run this shell file, what happens is instead of date that is there inside quotes in the output, the actual date will be displayed. The next line says echo this month's calendar is cal. You know that cal command displays the calendar of that particular month. So again, in the place of cal, the calendar of that month will be displayed. Echo my shell is $shell. So in this case, the shell is bash. So it is going to display my shell is bash. One thing that you have to remember is the symbol hash can be placed anywhere in a line. You can place it in between a line as well. But the only exception that you have to remember is it does not apply to the first line. In the first line, you have to put the hash only at the beginning and not anywhere else in the program. Like how we have scanf in C, we have read in shell scripts. So the same functionality of scanf is applicable in shell as well. So what does read do? It is used to make scripts interactive. That means we as users may give different inputs as different people. So if I give name as X, you may give name as Y. So I can just give read name to give the user a choice to enter his or her choice. So the read statement is the shell's internal tool for taking input from the user. It can be used with one or more variables. So in this example, I have said read name. So what is going to happen? The script pauses at that point to take input from the keyboard. Whatever you entered is stored in the variable name. So let's look at an example here. hash exclamation /bin/sh. So the name of the file is emp1.sh and the explanation says it is an interactive version, or it's just telling you what is going to happen in this program. Echo, enter the pattern to be searched. Now this \c is like any other escape sequence like \n itself. So it is just one character that you enter. Usually it is the enter key. Read pname. So if I'm searching for a pattern from a file, then I can give two inputs here. One is pname and one is fl name. So I'm searching for a pattern from a file. So what is happening here? Echo searching for $pname. So whatever pname that you have entered previously after executing read pname is replaced here in the place of $pname from file $fl name is the same file name that you have read using read. So grep, it is used for searching a pattern in a file. So the command is grep $pname $fl name. So when you execute this file, it will show you the output as whatever pattern that you're searching from whatever file that you have displayed. In the end, I have a echo statement which says selected records shown above. Let's see what is the output of this file now. Let's say the pattern that I'm going to search is director from the file emp.lst. So it will display enter the pattern to be searched and you will type director. Enter the file to be used emp.lst. Searching for director from file emp. So that is what is given here. Searching for $pname from file $fl name. So it is searching for director from file emp.lst. And if you see the output, it is displaying all the lines that have the word director. And it also displays the last line, that is selected records shown above, that you can see here. Next, you can use something called as command line arguments. Now these command line arguments are indicated by the symbol $ followed by either some numbers or some symbols. Let's see what they are. Like Unix commands, shell scripts also accept arguments from the command line. So when arguments are specified with the shell script, they are designed to certain special variables. So there's one tabular representation. We will see that in the next slide. The first argument is read by the shell in the parameter $1. So $1 indicates the first shell parameter. $2 indicates the second, $3 represents the third, and so on, depending on the number of arguments that are there. When you use a multi-word string command line argument, you must quote it. That means if a command line argument has more than one word, then you should enclose them within quotes for you to indicate that it is a single command line argument. So look at this table. This is a very important table here. $1, $2 indicate the positional parameters representing command line arguments. $hash indicates the number of arguments specified in a command line. If I say there are $1, $2, $3, that means there are 3 arguments specified in the command line. $0 indicates the name of the executed program. $* gives me the complete set of positional parameters as a single string. So it tells me the number or the total set of positional parameters in one complete file or a shell script. $@ each quoted string treated as a separate argument. Like we said, if we have multi-words in a single argument, then each of them are treated as separate arguments. $? Tells you the exit status of the last command. So we'll see what this exit status is in the next few slides. $$ indicates the PID of the current shell, and $! Gives the PID of the last background job. Let's see an example of how these positional parameters or command line arguments work. So there's one simple file called as s3.sh, And if you see, the shell here is sh. Echo program $0. So we said, what does $0 tell me? It tells me the name of the executed program. So my output after executing this file, the first line should be s3.sh. The number of arguments is. So let's assume that I'm searching for director from the file emp.lst. So the number of arguments, $hash indicates the number of arguments. So director is one argument and emp.lst is another argument. So the number of arguments is 2. And the arguments are $star. So it will list out the arguments as well. So in this case, it will display the arguments are director and emp.lst. And grep $1, $2. That means search for director in the file emp.lst. And then display echo -e \n job over. That means once after you have finished searching for a pattern, that is director from the file emp.lst, indicate that the job is done or print job over. Next is the exit status of the command. So you can have exit in either lowercase or uppercase. If you remember, we have it in C as well. To terminate the program, use exit in shell and exit inside brackets in C. So one thing that you have to remember here, the command is run with the numeric argument, or it returns 0 and a non-zero value. So when does it return 0 and when does it return non-zero? Through the exit command or function, that every command returns an exit status to the caller. The command is set to return a true exit status if it executes successfully and false if it fails. So if it returns a non-zero value, any non-zero value, that means the exit status is false. If it returns 0, that means its exit status is true. So cat foo. If cat cannot be executed or if foo does not exist itself, then it will say cannot open foo returns a non-zero exit status, that is false. Parameter $? Also stores the exit status of the last command. So if you see the table here, it says $? Stores the exit status of the last command. It has a value 0 if the command succeeds and non-zero if it fails. So let's see an example here. Grep director emp.lst write chevron /db/null echo $? That means search for director in emp.lst. If it is present, if you get some value out of it, then print the value, or then exit status is 0. That means I have successfully executed that command and I have found the result. I have found director in emp.lst. If I'm searching for manager in emp.lst and if I do not find any manager from that file emp.lst, then it returns a non-zero value. It can return either 1, 2 or any non-zero value. That means failure in finding the pattern. So basically manager does not exist in this file emp.lst. Now we'll see the logical operators and or. Conditional execution. You know this already. So it provides two operators that allow conditional execution. That is logical and logical or. The AND delimits two commands. The command cmd2 is executed only when cmd1 succeeds. We know that already. AND executes only when both are true. So if the first one itself is false, then it is never going to execute the second half of the command. So if there's an example here, grep director emp.lst and echo pattern found in file. So I am searching for director from the file emp.lst. So if you find the pattern director from the file emp.lst, then only print that pattern found in file. Otherwise, it will not print. Here we have an example where director is present in emp.lst. So it is going to display pattern found in file. Let's say I'm using OR. $grep manager emp.lst or echo pattern not found. So if manager is not found in emp.lst, then print pattern not found. So the OR operator plays an inverse role. That is, the second argument is executed only when the first fails. I have also told you this. Shorthand operator or shortcut. What happens here? In OR is executed only when the first one fails. If the first one fails, only then the second part is executed, because OR is true when either of them are true. If the first condition is true in the case of OR, it does not check for the second condition. The if conditional. The if statement makes two-way decision depending on the fulfillment of a certain condition. So you have to remember that if ends with fi. If command is successful, then execute commands. Else, execute commands and then end the if with fi. So let's see, there are multiple forms of if. So this is one simple if with an else. Here you have a nested if. If command is successful, then execute commands. This is a simple if. Form 2 is simple if. First one is if else. And form 3 is nested if. If command is successful, then execute commands. If commands is successful, then else fi. So the first part is simple if else. Second is simple if. And the third one is a nested if else or an if else statement. Using test and rectangular brackets to evaluate expressions. So test is used to handle the true or false value returned by expressions and is not possible with the if statement. So you do not use test with if. Okay, it is just used along with an expression. So test uses certain operators to evaluate the condition on its right and returns either a true or false exit status, which is then used by if for making decisions. So if does not use test directly, if uses the result of test and then makes decision. So test works in different ways, that is 3 different ways. Compares 2 different numbers, compares 2 strings or a single one for a null value, checks for file attributes. So let's see each of them one by one. Numeric comparison. Operators always begin with a hyphen followed by a 2-word character word and enclosed on either side by a white space. So you can have different operators: equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. So equal to will be specified by EQ. Not equal to is specified by NE. Greater than is specified by GT. Less than is specified by less LT. So here, let's see an example. Numeric comparison in the shell is confined to integer values only. Decimal values are simply truncated. So you cannot use decimal values. You can use only integer values. So let's see an example here. X is defined a value 5, Y is defined a value 7, and Z is defined a value 7.2. So observe here, whatever is given on the right side in italics is the output, or it is the comparison that is made, and whatever values 1, 0, 1, 0 are there, they are the result of the numeric comparison. So you can have either true or false. So first expression is test $x hyphen EQ $Y, echo dollar question mark. So what does question mark, dollar question mark do? Dollar question mark gives the exit status of the command. So it can return either 0 or a non-zero value. So here, $x is 5. Is 5 equal to 7? It is not equal. So it has to return a non-zero value. So it is returning 1. The second example. Is $x less than $y? LT stands for less than. Is it less than y? That is 5 less than 7? True. So it returns 0. $test $z greater than $y. $z is 7.2 is not greater than 7. Why? Because 7.2 is truncated to 7. 7 is not greater than 7. It is equal to 7. So it is returning a false status saying 1. Next one, test $7 equal to $z equal to $y echo $y. So it says is, what is the value in Z? 7.2. 7.2 equal to 7. True? Yes. In this case, Y? In general, 7.2 is not equal to 7. But the value stored internally instead of 7.2 is 7 itself. So 7 is equal to 7, which is true. So it returns 0. So this is the example, or these are the shorthand operations that we have. Equal to is minus EQ, not equal to is minus NE, GT greater than is minus GT, greater than or equal to is minus GE, less than is minus LT, and less than or equal to is minus LE. We can have string comparison as well. How do you do string comparison? So the first line is $#bin/sh, and the file name here is emp1.sh. So what is it doing? It checks user input for null values. Finally, returns emp.sh developed previously. So look here. If $# minus EQ 0, that means $# tells me the number of arguments. If the number of arguments is 0, that means nothing has been entered. Then, if that is true, then echo enter the string to be searched. Read pname. Now I am asking the user to check if the number of arguments is 0. If the number of arguments is 0, only then read the pattern. Again, if I don't enter any pattern, then it will return a null string. If I simply press enter when it asks me for pname, then it should return something saying you have not entered a string. So see carefully, the output of it is shown in the next slide. So read pname. If minus z $pname. So minus z checks for a null string. So null string is an empty string. If it is an empty string, then it should give me a printing statement saying you have not entered the string. That means exit 1. That means you have failed, or you have not entered anything, so your execution has stopped. If not, if you have entered something, if it is not a null string, then it will go here and it will ask you for the file name to be used to search for this pattern. Read a file name. Now, you might give a pattern, but you may not give a file name. So if $-n $file name, that means you have not entered a file name. That means it is same as Z. That is, Z checks for null string. Here minus n also checks for null string. If you have not entered a file name, then you have not entered file name. So exit. So if you have entered both of this, then it is going to simply say emp.sh $pname $file name. So it will just display the pattern that you have specified and the file name. Else emp.sh $star, that is, it is going to display all the arguments. So let's see one example here. Let's say in the first try, I'm not going to enter the string itself. If I do not enter the string, simply I press an enter key. Then it will give me, you have not entered the string, and it will exit from the program. Why? Because I've not entered the string, there's nothing to be searched. Next example is, if I have given root as the string to be searched, and if I find or if I enter the file name to be used as /etc/password, then it is going to display the output for me like this. Okay. There is another tabular representation which tells me what are the different types of files that I use, what are the different ways in which I can perform tests on files. So let's say I have an example here, emp.lst, and I'm trying to list out the attributes of this file emp.lst using the command ls-l. So this is already done in file attributes chapter. So ls is used for listing the attributes. And from a file, if I specifically want it, then I give ls-l. I'm trying to find out if this file emp.lst is an ordinary file or an executable file or what. So this letter -f indicates that it is an ordinary file. So if it is an ordinary file, then it has to return 0, or it will return 0. If this emp.lst is an executable file, then it will return 0. But in this case, it is not an executable file. So it is returning a non-zero value, that is 1. So next condition that I'm checking is if it is a writable file. So $!w emp.lst or echo false that file is not false that file not writable. Maybe this file is writable. So it is just going to make a comparison. If this is not true, if it is writable, then it will print false that file not writable. That means it is writable. So the same thing here, echo e -e checks for if the file exists or not. So if you observe, the symbol negation tells if file does not exist. E for exist, not E for does not exist. So I can use it with R as well. R for if the file is readable. Elif, so instead of else if we have elif. Elif -$1, then file is not writable. Else, if none of these are true, then you say that file is both readable and writable. That means if, see, this is negation of -r, that means it is readable. If I remove this exclamation symbol, then it is checking for if the file is readable. So if I put exclamation sign, then it's checking for not readable. So this is the thing that we have seen already. -f checks for if file exists and is a regular file. -r if file exists and is a readable file. -w file exists and is writable. -x file exists and is executable. -d for file exists and is a directory. So I'll stop this here and I'll continue in the next part.